Now that we know the basic trig graphs, we can shift them around and stretch or squish them. Here's our standard sine graph. Let's see how to modify it. The simplest change we can make is to add or subtract a number to the sine function. For instance, if we want to graph sine of x plus 2, it means we'll make all our output y values 2 units larger. Notice that I reinstated parentheses around the x variable just to make it clear that the plus 2 isn't being done to the x variable itself. This has the effect of shifting the graph upward 2 units. If you want to move it downward, subtract 2. If you multiply the sine function by 2, so that our equation becomes y equals 2 times sine x, every y value gets doubled. This will stretch the graph vertically by a factor of 2. Notice that points on the x-axis stay there, but the rest of the graph is stretched away from the x-axis. You can multiply by any scale factor you like. If you want to shrink the graph vertically, multiply by a number smaller than 1, like 1/2 or 0.7. These modifications so far only affect the vertical direction. If we want to change the graph horizontally, we have to make changes to the input variable x itself. A little forewarning, this isn't quite as straightforward as our previous transformations. Let's say you'd like to shift the graph to the right 1 unit. A common first guess is to use x plus 1 in the equation. If you let a machine graph that for you, you'll see that the graph shifts left rather than right. Why? To investigate this, let's trace what happens with an input value. We'll zoom in for a closer look. Let's say we want to plot a point where I just drew that green arrow. When we send that input into the equation, the first thing that happens is 1 is added to it. Then it goes through the sine function. The value we are pulling from the sine computation isn't from our input x itself, it's from x plus 1. We take that sine value, and it becomes the y value for our initial input. The plus 1 in the equation was telling us to look to the right 1 unit, get the sine value there, but then plot it where we started. It has the effect of pulling points left 1 unit. Let's see the idea again. Choose an input value, look 1 unit right to get the output value, bring that y value back left to your location. One more time using numbers. Although these numbers won't actually be accurate to a sine function, let's just go with it for the sake of the illustration. You want to find the output value for x equal 4. You put that into your equation, which becomes sine of 4 plus 1, namely sine of 5, and you plot the result back at 4. You look right 1, pull it back to the left to plot it. Do this with all the points, and the entire graph moves left 1 unit. Alright, back to our regularly scheduled program. We saw that graphing sine of x plus 1 shifts the graph left. So now it should be no surprise that if we graph sine of x minus 1, it will shift the graph to the right 1 unit. If we multiply x by 2, it doesn't stretch the graph by a factor of 2, but rather compresses it horizontally. Similar to what we saw before, this is because the 2 multiplier tells us to look twice as far away to grab our output y value and then bring it back to our location to plot it. The stretch is in how far we go to get our points. When we bring them back, it's a shrink. If we would like to stretch the graph horizontally, we'll need to multiply x by a factor between 0 and 1. For instance, if we plot sine of a half x, it will stretch the graph by a factor of 2. The good news is that these transformations aren't special to trig functions. If you understand how they work, you can stretch or squish or move any graph you like. For example, here's a nice half circle and its equation. I'll use function notation so we can keep a sharp eye on what our modifications are. If you'd like to shift the graph upward 3 units, no problem. Just add 3 to the output. If you'd like to stretch the graph vertically by a factor of 3, multiply the outputs by 3. If you want to shrink the graph horizontally by a factor of 3, you would multiply x by 3. But that has to happen for every appearance of x. You aren't really just inserting a 3 somewhere. You are replacing x by 3x every time it shows up. And finally, to shift the graph right, let's say 2 units, you want f of x minus 2. Be careful with that equation. Okay, enjoy your stretching and squishing.